Alright guys, this is the entropy of a black hole. What do we have? This is the Boltzmann constant. This is the area of our black hole, and this is the Planck't length of the it is the Planck't length. So we calculate how many Planck't length we have into this area, and this what is this finally? The Planck't length is a sort of spatial unit equivalent to time, Planck's time. So we calculate the entropy of a black hole according to the numbers of a sort of maximum de Broglie wavelength that could be contained into the area of a black hole. But the thing is strange is that y is just on 2 dimension. It's because the event horizon, because maybe we can, it's not obvious question, you know, to me. It's because we see the event horizon like a line. And the question is that could we transform this relation into a sort of using the Planck's time, and then replacing the spatial area by a time area, which will be a time square. So we could say technically that we can, I don't know if it works, it's a good question, but we're gonna to take also Boltzmann, we're gonna to call, we're gonna to use Planck's time here, square, and here we could say that we could use, I don't know which letter, but we could use I don't know, something I will call D, and this is the time area of the black hole. So what is the interpretation we could have made if we transform the entropy of a black hole using space by using time? I don't know really, but maybe what I could say for first approximation is that this is like a space square, and this is time square. And when we have the Lorentz transformation, we know that ds square equal to ct square minus x y z square. And so we have space square, which is equivalent to that, and here we could say this is a c square time t square. So in a certain way we have time square, which is interesting. And since we have time square, we multiply by c, we have the maximum available space, and this is equivalent to a sort of Thevenin-Norton principles. I know I'm crazy, and then we can interpret that like exactly as a very basic electrical generator with E here. I'm gonna to show you and a resistor here, and a load here, and the and the voltage here around these resistors is equal to E. It's not energy, it's the voltage. It's the voltage of the generator minus, this is R, and I. I will call I is the current passing through the circuit. And so we have the potential minus the used current, and we have voltage over this load. This is load. All right, so it's I don't know. I know it sounds not habitual, but it's could be working like that. When your space is equal to that, this has become zero, right? So your space-time distance become zero when you reach the speed of light. If you reach the speed of light, in a certain time and certain space, your space-time distance becomes zero. For example, photons, the photons reach the speed of light. So this is 300 kilometers, the distance that's light making in 1 second, and you put 1 second, you will have ds is equal 0. So why not? Could make the black hole entropy with different expression, but this is interesting because this is length Planck't and this is time Planck't. It's interesting because it should work both. And it's interesting because here we have the Broglie wavelength, maximum spatial shortness wavelength, and this is my time wavelength, maximum shortest wavelength available.